Hi all, previously we have learned about transport layer protocol, which is called TCP or Transmission Control Protocol. There is another popular transport layer protocol which is called UDP or User Datagram Protocol. So next I'm going to show you on this UDP protocol in more details. UDP offers an interface to send internet protocol packets just like TCP. However, we can call UDP as an unreliable connection-less datagram service. It uses internet protocol and it adds additional address, which is port number, to distinguish or to differentiate between different communication relations. This is because UDP adds nothing to the internet protocol. When a developer chooses UDP instead of TCP, we can say that the application is almost directly talking with the internet protocol. So UDP will take the message from the application process, attaches source and destination port number, and adds two other small fields and passes the resulting segment to the network layer. So when the segment arrives at the receiving host, UDP will use this port number to deliver the segment data to the correct application process. So that is why the port number here is needed to differentiate between different processes at the application layer. Because UDP is very simple, it has low additional complexity and overhead to the internet protocol compared to TCP. However, to make UDP reliable, higher layer protocol will need to deal with the packet loss, packet reordering, packet duplication, and loss of connectivity because UDP does not guarantee all of these unless compared to TCP. Now comes the question, why we use UDP? To answer this, recall that UDP does not give any guarantee of the service. Hence, we can say that UDP makes best effort service or best effort attempt to deliver the data. So, on the way to deliver the data, UDP segments may be lost or it can be delivered out of order to the application. However, there are some applications that can tolerate some data loss. For example, streaming multimedia application, which it can tolerate with the loss, and also it is rate sensitive. In addition, UDP also is a connection-less protocol. Why? Because there is no need to establish a connection for UDP unlike TCP. It means that there is no handshaking between UDP sender and also receiver. And each segment in UDP is also handled independently of others. Because of this, UDP does not introduce any delays to establish a connection. This is basically the reason why applications such as DNS is run over UDP rather than TCP, because if DNS is run over TCP, it will be much slower. However, some application, for example, HTTP, uses TCP rather than UDP because it needs reliability, which is critical for web pages with text. UDP is also simple because there is no connection state that needs to be maintained by the protocol, unlike TCP that needs to maintain connection state such as receive and send buffers, congestion control parameters, and sequence and acknowledgement number parameters. UDP, on the other hand, does not maintain any of these states and does not track any of these parameters. So for this reason, for example, a server devoted to a particular application can support more active clients when the applications are run over UDP rather than TCP. UDP also has smaller header size. Because of that, it is more simple, unlike TCP, which has 20 bytes of header overhead in every segment. UDP only has 8 bytes of overhead, which is a huge difference between UDP and also TCP. Because of its simplicity, UDP does not offer any congestion control. So to add the reliability over UDP, it needs to be added at the application layer. Also, for specific application, it needs to add error recovery. So the next slide shows UDP format in terms of the segment, UDP segment. So we can see here the first one is the source port, which takes about 16-bit of numbers, and then these port numbers, okay, the first one is source port, the next one is destination port. So these port numbers allow the destination host to pass the application data through the correct process running on the destination end system, because we know that there are many applications or processes can be run over one system. The length field here takes 16 bits. It specifies the number of bytes in the UDP segment, which is header here, plus the data. So an explicit length value is needed since the size of the data field may be different from the UDP segment to the next. This is in bytes. Another field here is checksum. It is used by the receiving host to check whether errors have been introduced to the segment or not. So in truth, the checksum is also calculated over a few of the fields in the IP header in addition to the UDP segment. So the checksum here is not only for UDP segment but also at the IP header. It is used to determine whether bits within this UDP segment have been altered, for example, because of the noise as it moves from source to destination. And finally, this is the application data or payload that occupies this data field of the UDP segment. So, for example, applications such as DNS, this data field will contain either query message or response message. For example, such as streaming audio, this application data field will be filled with audio samples. Next, this slide shows the well-known ports for UDP. So, as we all know, at the UDP header, it has field for destination port address as well as source port address. This is to differentiate between different processes run over UDP. So, let's see one of the example here. The family example here is DNS. It uses port number 53. So, please recall that DNS means domain name server. A client-server application such as DNS uses UDP because a client needs to send a short request to a server and to receive a quick response from it. So UDP is more suitable rather than TCP. So for DNS request and response, it can each fit in one user datagram. Since only one message is exchanged in each direction, the connectionless feature is not an issue for UDP, and the client or server does not need to worry that messages are delivered out of order because there is only one message. However, a client-server application, for example, electronic mail, cannot use the services of UDP because a user might send a long email message, which could include, for example, multimedia, images, audio, or video. So, if this application uses UDP, and the messages does not fit in one user datagram, the message will be splitted into by the application into different user datagrams. So here the connectionless service may create problems because user datagram does not the packets for user datagram does not numbered. So the user datagrams may arrive and be delivered to the receiver application out of order. So this will create a problem because the receiver application may not be able to reorder the pieces, unlike DNS, which just uses one short message. So in the next slide, we can see some of the popular internet applications as well as the application layer protocol and the underlying transport protocol that is used by all these applications. For example, electronic mail or application layer protocol is SMTP. It uses TCP rather than UDP because of the reason that I have told you before, where this email can be splitted into different segments, in which if we use UDP, it will raise a problem of out of order delivery. And remote terminal access, web, and also file transfer also use TCP. For the remote file server, that uses application layer protocol NFS, it typically uses UDP. For streaming multimedia or internet telephony, which the application layer protocol usually belongs to the big organizations, so it may use UDP or TCP depending on its specific user. For other applications such as network management, routing protocol, and name translation, these applications used UDP rather than TCP. Besides UDP and TCP, there are also other popular transport protocols. First, there is another transport protocol called Stream Control Transport Protocol, or SCTP. So for further information on this SCTP, please refer to RFC 4960 or RFC 3286. So I'm not going to explain into details on other transport protocols. So for our syllabus, I only explain on the UDP or TCP in details. So this Stream Control Transport Protocol, the purpose is to be used for message oriented because it allows several different application level streams to be multiplexed through a single SCTP connection, or in other words, this SCTP allows multi-streaming. So this is for newer applications such as voice over internet. Basically, it combines the best features of UDP and TCP. The flow and congestion control is similar as TCP, and it is mostly designed for internet applications. For SCTP, it preserves the message boundaries like UDP. However, at the same time, it provides reliable service such as TCP. For example, it can detect lost data, duplicate data, and out of order data. It also has this flow and congestion control similar to TCP. Another popular protocol is Real-Time Transport Protocol, or RTP, which can be found in RFC 3550. But this RTP runs on top of UDP to provide unreliable transport of media stream, for example, voice or video stream. It is also used together with RTCP. RTCP means Real-Time Transport Control Protocol, which this RTCP is used to monitor the quality of service. So, just like UDP, it does not provide any mechanism to ensure timely delivery of data. Means it does not guarantee the QoS delay, quality of service in terms of delay. It does not even guarantee delivery of packets or prevent out of order delivery of packets. This RTP is used together with RTCP to provide to allow control messages that can control the flow and quality of data and allow the receiver to send feedback to the sources. So some of the SCTP applications, okay, you can see here the protocol used, the port number used, and also the description. For example, the ISDN over Internet Protocol, the SS7, which stands for Signaling System Number 7, Telephony Signaling Protocol, Media Gateway Protocol, and IP telephony. So these are some of the examples of the SCTP applications. And finally, the final slide here shows the comparison between transport layers, popular transport layers such as TCP, UDP, and SCTP. So you can see the features here and whether TCP, UDP, or SCTP provides that feature. So as we can see here, both TCP and SCTP are connection oriented, unlike UDP, and we can say that TCP and SCTP is a reliable transport protocol. However, TCP does not preserve message boundary, because remember that TCP provides a stream of message delivery to the receiver. Unlike UDP, it has message boundary, and SCTP combines the best feature of TCP and UDP, and thus it has a message boundary here. And UDP does not guarantee ordered delivery compared to TCP and SCTP. However, SCTP can also provides unordered delivery, just like UDP. All these three, TCP, UDP, and SCTP, provide data checksum, okay, in terms of this number of bits. And for the pass MTU or maximum transfer unit, UDP does not have one. Congestion control also UDP does not have one. And UDP and TCP are not suitable for multiple streams, unlike SCTP. And it does not have multi-homing support. Multi-homing support means to connect to 2 or more ISP or internet service provider. And TCP and also UDP does not offer data bundling. This chunk bundling is only a function of SCTP, which is responsible for assembly the complete SCTP packet and disassembly at the receiving end. So I think that is all for the things that you need to know for UDP. So the next slide or the next chapter will be chapter 4, which is the network layer. So see you at the next video.